Okay, up until now we've been focusing on responding to the mouse in terms of activity. It would be ideal if we could use something a little bit more sort of game friendly, like the game controller. Consequently, this tutorial basically revolves around, first of all, just responding to the D-pad buttons on a game controller, and also identifying how we can adapt the mouse click code that we had before into one that responds to a button on the game controller. So for today, all I need you to do really is open up this project that you've already got. It gives you a blank player, which we're used to by now. You'll also find that there is code already added to it that basically resembles what we did with a mouse click, but responds to the button instead. So the button we're responding to on the controller is the green A button. As you can see, we still have in our code exactly what we had before. The only thing is, just to give the code meaning, I've changed the left mouse button to A button. Okay, and its initial state, as before, was set to released. So we still have this Boolean A button clicked method. Now, realistically, it's been renamed just slightly to reflect the controller. It has exactly the same code, it's just been adapted very slightly to correspond with accessing a game controller. So if we actually look at the changes, so you understand what changes have been made, before we were always looking at mouse.getState. Now, because we're working with a gamepad, we're looking at gamepad.getState. Now, the difference between that and mouse is that you can also have a player index. Okay, so a player index allows us to have multiple controllers connected. I believe, if I remember correctly, that the player index goes up to 4, so you could have up to 4 USB connected gamepads all at the same time. So you can have 4 players on screen if you wanted to. Now, whereas before we referred to things as left mouse button, right button, etc., with getState on a gamepad, the gamepad has actually been segregated up into smaller parts. So for example, there's a buttons option, and within there you can also specify which button it's going to be. So in this case we're looking at button A. Okay, as you type this, as you'll see a little bit further down, you'll also see that this auto completes for you. But it's exactly the same principle. You look at the gamepad in its previous game state, and then you look at it in its current one. So if it's released, and then previously, and now it's pressed, we do exactly the same. We return true to say that we've had a click, and we store that data in the A button variable for next step. So we're not actually going to use that directly right at this minute, but you've already encountered that through your code that you did with the mouse, so you should be aware of how to deal with that. If not, just look at the previous example. The code is exactly the same. You literally just change where it says left mouse button clicked to A button clicked, and it will all function correctly. What we are going to do though is we're going to adapt the update method. So up until now, that update method was full of code that was to do with a mouse. I've cleared all of that out. We've kept the animation call in there of next frame just to keep it animated. But what we need to do now is we need to, first of all, add in something that responds to the controller. Now this introduces a new concept that you're not used to. Prior to this, because you were using a mouse, you generally wanted to update where the sprite was based on where the mouse was on the screen, so we just modified the position of our sprite. When we're using controllers and keyboards, we tend to work on the idea that we're in a current position and we want to move in a particular direction. Okay, and when we specify directions, we tend to deal with that on the idea that we're going to move so much in the X direction and so much in the Y direction. Okay, and they'll be proportional. So the way that we do that is we use our game controller to make a decision as to how much to move in a particular direction. And because we're going to talk about the D-pad, we're going to keep it at the moment as for every 1/50th of the screen update time, so in other words every 1/50th of a second, we're going to move 1 pixel in a particular direction based on where the D-pad is being pressed. So if we're pressing up, it will move 1 pixel up every 1/50th of a second. If we're pressing right, it will move 1/50th of a second right. 1/50th of a second, it will move 1 pixel right. If we happen to have a couple of buttons pressed at the same time, our code will cope with that, and our controller will be absolutely fine to trigger the fact that both buttons are being pressed at the same time, so it will move diagonally if we need it to. The obvious thing to say is, as we know from previous courses, that the D-pad itself is a digital thing, so we only get ones and noughts. That means we can only be pressed or released. In a later episode of this, we will look at the idea of how you respond to a thumbstick, which will obviously give you a variable value, which might vary how fast you move. Right, so it's actually really simple. The first thing we need to do is make sure that our direction is set to 0. So before we start deciding where we're going to move in terms of direction, we first of all set the direction to 0. So that's quite simply done. We've already got a direction vector 2 in our abstract sprite class, which we've inherited. So direction equals, and then all we can do vector 2 dot 0. Okay, and that will set your direction to 0 from the start. That just clears out any previous movement from the last time the screen updated. The next thing is we just need to put in a series of if statements that actually control which direction to go based on the pressing of the buttons on the D-pad. So if, and then we look at the gamepad. Get state. We need to put in which player it's going to be, so we're going to do for player 1. Okay, so that means we're looking at the first controller. Then we want to look at the D-pad. So this is where we start to look to see how it's all structured and cut down so that we can easily deal with different parts of the controller. So we've got buttons, D-pad, we've got things like is button up, which allows us to look at individual things as well. We can also check to see if the controller is connected. There's a little bit about information being transmitted, and also the thumbsticks, which we'll talk about later, which are analog, and the triggers as well. But for the moment we're going to deal with D-pad. Right, so when we select D-pad, it then allows us to decide which button's being pressed. Okay, so we've got up, left, right, down. Okay, so the first one we're going to deal with, there's not particularly an order that's important. We'll deal with left, okay, because that's an x-axis thing. So left on the screen is where we're going, and then basically what we're doing is we're checking to see if that's been pressed. So it's back to this button state. Okay, so if that button's been pressed, the left button, what we need to do is we need to set the direction we're going to move this sprite in. So direction, and because it's a vector 2, it has an x and a y. X is what we're modifying. And then what we can do is we can give it a specific value. So because we want to move left when we press the left button, what we're actually doing is bearing in mind that the left hand side of the screen is going to be 0 and the right hand side is going to be a positive number. To move to the left we use a negative value, so -1 means move 1 pixel, okay, on the screen, and at that point that will work. Now what we want to do is we want to be able to do that for all the buttons, left, right, up, down. Okay, so left and right obviously modify the X, up and down modify the Y direction. So just for simplicity's sake I'm going to copy and paste to deal with the 4 separate buttons on the D-pad. The next thing we're going to do is adjust them, so left and right for me logically go together. Up and down also. Okay, so we've responded to left, right, up and down. Now we need to modify for left and right the X direction. So we've already said left is a minus number, so obviously right is a positive. Alright, now we're also looking at the direction in Y. So we need to modify those two things as well. Now bearing in mind that top of the screen is 0 and bottom of the screen is a positive number, if we want to go up then it's a negative direction. If we want to go down it's a positive direction. And at that point we've actually done all of the code that we need to deal with the gamepad itself responding and you controlling that sprite. So at the moment there'll be no mouse clicks obviously, but if we start the program up, what we'll be able to see is obviously we start in the top left hand corner now because that's the default for the sprite. Okay, we can move it around, you can move diagonally. Okay, it's not very exciting I know, but at that point we've got all the control things. Apparently it's Steve Jay's birthday, thank you very much, we'll get rid of that. Very appropriate, thank you Microsoft, always good to know. Other things that we can do is we can also respond to that A button clicked event now. At the moment there's nothing on there. We could, at the moment it's animating all the time, but maybe we could make that so that it only animates after we've clicked the button, so it stays as a stationary one, but once we've clicked it then it actually calls the next frame, so it actually each click will move the frame one animation on. So if we wanted to do that, we can put if A button clicked. Okay, and just for clarity's sake, we don't really need to do this because we're allowed one line of code after an if statement, but we'll put brackets around it. It does make things a little bit more clear. Now at that point, that means that we won't have an animated sprite now, we'll have a stationary sprite, but every time we move or press the A button, we're going to get another frame activating. So at that point, let's just move it onto the screen so we can see it. Right, each click of the button moves it onto one more frame of animation. Now in certain games that might actually be quite useful. You may be using that as a, rather than a left and right, you might actually be animating left and right. You might be rotating something left and right, so that's quite useful in its own right. So in summary, what we've got is we've got some very simple controls that allow us to respond to the game controller. The main things that you need to know is everything about that game controller is held in get state. We can say which controller we're using by specifying the player index. This is all digital, and as always we're checking for button state pressed. The moment we move on to anything to do with analog, we then have to deal with basically long calculations in relation to how we're going to make that work with our sprite direction. We'll need to look at that in more detail, so we shall leave that one till later on.